Well, hello everyone. I'm James Rubin. I'm going to be the moderator for this fireside chat with my esteemed Google colleagues, Peter Grabowski and Peter Danenberg. We're going to be touching on the key blockers and solutions to productionizing enterprise-ready LLMs and talk about some of the state-of-the-art approaches to really solving those challenges. We want to really focus on the practical applications today, and we hope this is really a jumping off point for folks. It's a conversation starter for folks, and we'll be in the media lab later if we have any more deep dive questions. But I think before we dive in, maybe we'll start with some introductions. I can go first. I'm James Rubin. I'm a product manager at Google for a Gemini applied research team. I work with Peter Grabowski. I'm his product counterpart. Prior to Google, I was at Amazon as a PM for the better part of 3 years, worked across the AI stack, beginning with Zoox, which is their self-driving subsidiary, but also on custom AI chips and machine learning services at AWS. And with that, I guess I'll pass it off to Peter Danenberg.
Hi, so I'm Peter, and so I work on Gemini, which was formerly Bard, and before that was Assistant. So Peter Danenberg on Assistant, formerly Bard, Gemini, formerly Bard, formerly Assistant. And I've been a senior SWE for a while, currently working on Gemini extensions.
And my name is Peter Grabowski. I am lucky enough to work with James on the Gemini Applied Research team. I've been at Google for about 10 years, came in through the Nest acquisition, then spent some time working on the Google Assistant. And then the evenings, I moonlight as a teacher. So I'm on the faculty of UC Berkeley's Master's in Data Science program and teach deep learning with natural language processing.
And one thing I'll add there, Peter is too humble to say it, but during really the height of the AI craze in early 2023, he created and taught a LLM bootcamp that has really become the foundational course for Google. It's been taken by tens of thousands of Googlers, including myself. So we definitely have two incredible experts on the stage today. Before we dive in, though, I want to discuss kind of what the motivation for this talk was. A recent survey from Andreessen showed that the overwhelming majority of enterprises adopting AI are choosing to build AI apps in-house on top of common foundation models. And this is as opposed to leveraging B2B AI software off the shelf. There may be a founder in the audience today that disrupts that trend, but regardless, the thing that we're most interested in is this disconnect between that enthusiasm to build and this hesitance and slowness that we're seeing with enterprises to deploy LLMs externally in production. Internal apps we're seeing, testing we're seeing, use cases for employee productivity, but when it comes to external apps, comparatively they lag behind. So we really want to keep that in focus today, and we want to focus on ways that perhaps we can make the process of productionizing these LLMs a bit more clear. So with that, I thought we'd just level set with everyone and maybe start with the basics. Peter G, how would you describe an LLM?
Yep.
And why should businesses care?
Happy to. So I'll give a really simple example, but hopefully it's got some strong pedagogic value. LLMs are really nothing more than fancy autocomplete. You might have heard that metaphor before. And so if I said, or if I gave the audience a prompt, I went to go see a baseball game last night, I got to see the Boston Red Sox. Hopefully everybody's thinking about socks. That's at their core what LLMs are doing. Now, with short context windows or just a little bit of data, that's not all that interesting. But when you start showing these examples or giving them billions of parameters to learn with and start showing them hundreds of thousands or millions or billions of examples with longer and longer context windows, you start to see some really interesting behavior emerge.
And I think one thing that we may want to expand on a bit is the fact that LLMs aren't just good for next word prediction and chat, but actually can be used for a wide range of traditional ML approaches as well. So perhaps just unpack that for us and also talk about the ways in which tasks can be reframed to work with LLMs.
Yeah, and so that's one of the things that's super interesting. Once you get into the couple billion parameter size, you start to see these fascinating properties emerge. So if you've heard the term zero-shot or few-shot learning, that's what folks are talking about. If any folks in the audience either have a 2-year-old or are ML engineers, this is the answer to the question you might have had. which is why can I show my 2-year-old a picture of a zebra and show her maybe 2 or 3, and then on the 4th, she's able to correctly identify what a zebra is. But if, with more traditional machine learning techniques, you needed to show 10 or 20 or 30,000 images of a zebra. So I think that's what James is alluding to. The other thing that's really interesting is you can start to recast many of these traditional ML problem framings as next word prediction problems. So if I gave you a sentence and then I gave it the prompt, this sentiment of this sentence is blank, it would happily fill in positive, negative, neutral, happy, sad, and all of a sudden you've reframed a classification problem into a next word prediction problem.
Awesome. So basically no excuse for businesses not to think creatively about how to apply LLMs to their use cases. Plenty of solution space exploration there. Peter G., I want to get your insights on this, especially how LLMs with these traditional ML approaches compare in terms of performance and how people are using them.
So one of the things we do every couple of weeks is we bring startups to Google to just ask how they're using AI, what are the difficulties they're having with Gemini, this and that. And so a couple of weeks ago, I learned that a lot of startups are doing this thing where they train a bunch of baby models, that's sort of a Gemma 2B model, on things like classification tasks. So they can go to market in something like 6 to 8 weeks, whereas previously, even just to train a trivial model as a classifier would take 6 to 12 months. So we've been seeing this quick time to market using baby LLMs as classification engines, trained on maybe tens of examples, which is incredible.
And actually, this is a great way to get us back from that slight digression, which is what is the shift in LLMs that makes them especially attractive to businesses?
Yeah, that's one of the things my team and I are really excited about, which is all of a sudden to train a classifier, to train a model of a fixed quality, the amount of time that it takes, the amount of data that it takes, the amount of expertise that it takes, the amount of compute that it takes has fallen dramatically. So that's one of the things we're exploring on our team.
Absolutely, and I think there's actually one important one we missed, which is customizability, right? The ability to tune and align models to a specific task or domain. Businesses have vertical use cases, specific customer problems they're trying to solve. So this is incredibly important. And I actually want to drill down on that a bit further and get your insights. Data shows that customizability is one of the top 2 selection criteria for enterprises selecting a model provider. But the process for going about customization is very complex. There's many different tuning techniques. There's many quality and cost trade-offs. It's very difficult to get to the output that you want. So perhaps, Peter, starting with Peter G., give businesses a starting point to navigate this complexity.
Yeah, 100%. So I saw this in my own work. I worked on the Google Assistant for a number of years. One of the things that we were focused on is building a sentence simplification engine for kids. And so if you ask, why is the sky blue, and you're an adult, you might get an answer like refraction in the ionosphere. But if you're a kid, that's not a satisfying answer. You want something like it bounces off a water drop that's in the sky. And so I spent about, like you were saying, 6 to 8 months trying to build a model with Google Research and launch it into production. We were able to build something that works, but it wasn't high enough quality to ship. Fast forward to a year ago, with the few-shot prompting techniques that we were talking about, I was able to build something that blew the model we had built 5 years prior out of the water. And so that to segue, that's the advice that I would give to businesses. Think about the problem that you want to focus on and solve using a large model, and then just get started. You can start by asking a model a question, just like we were talking about a moment ago.
So let's say they set up a sandbox, they run an internal pilot, they've got their metrics set, they're gathering data. It performs really well on general tasks, but it's not quite ready to specialize in their domain. It's not ready to replace some of their domain-specific workflows. What are some more advanced approaches they can now take?
Yeah, and you touched on one thing that I think is really important to emphasize, which is make sure that you've got metrics in place so that you can measure when you're improving. And so in this case, maybe we can talk about a hypothetical example of using a legal startup. Maybe you want your chatbot or your agent to talk and sound like a lawyer. The first thing you might do is try what's known as role prompting, which is just telling the model to talk like a lawyer. From there, I would, again, evaluate, measure, see how you're doing. And if it's not where you want it to be, there's a couple other techniques you can try.
Definitely dive into those, especially with regards to domain knowledge and domain specificity.
Sure. So the next thing I would think about trying is what's known as a family of techniques known as domain adaptation. And so the first thing you might try is continued pre-training. And so what you're doing is you're taking that language modeling task that you started with, predict the next word, you're using backpropagation to update your weights, but you're focusing it on a corpus of data that's relevant to your model. And so for instance, in this legal example, you might do continued pre-training on a corpus of law textbooks. To give a human analogy, that's like telling a first-year law student to go read 50 legal textbooks and come back and talk to me more like a lawyer.
Awesome. And what about things like classification, given we mentioned it earlier, or chat, where we're talking about really adapting the task that the LLM is doing rather than the domain background?
Yep. That's a great question. So if you're asking the model to make a decision about some sort of case law or something like that, continued pre-training can absolutely help. You might decide to focus it on specific examples of the task you want it to do. And so if it's a classification problem, you would train it using backpropagation, using the next word prediction task to do that specific focus on that task. And so that, in that context, it's usually known as supervised fine-tuning.
Awesome. So to summarize, for domain knowledge, domain specificity, continued pre-training is a good place for people just to start. If you're looking to improve a very specific problem framing, a very specific task, SFT is a good place to start. But there are, as we know, and you know more than most, there's many other techniques to explore within that, but we can talk about that maybe outside later. Peter D., I feel like we've ignored you a bit here, but the examples that Peter G. gave were with use cases where basically quality and accuracy can be defined pretty concretely. A legal chatbot you can evaluate against an LSAT, classifier you can measure accuracy and precision. What about use cases where quality is defined more ambiguously?
Yeah, it's interesting. So I don't know if this is a West Coast thing, but we had a bunch of startups come to Google a few weeks ago who they're trying to solve this personal companion problem. And there seems to be a lot of VC money in that. Is that a West Coast thing, by the way? You guys doing that East Coast? So anyway, we had this little experiment, right? So let's see if we can fine-tune a Gemini model to be like Sherlock Holmes or Elizabeth Bennet. And so we ran this experiment where, we tuned a Sherlock Holmes with about 10,000 examples, right? And there was this really bizarre phenomenon where this fine-tuned Sherlock Holmes didn't seem to know that he was in a book, right? And so he would answer in the first person, which is a little bit strange. If you do the same thing with vanilla Gemini, you'll notice that, Gemini speaks as Gemini with a little bit of Sherlock Holmes lipstick, essentially. But, one of the funny things was, though, is that, how do you evaluate this fine-tuned Sherlock Holmes versus a vanilla one? And, is it enough just to say, hey, Holmes, by the way, do you live at 211B Baker Street? And, it turns out it's not. And, especially when you're talking about these AI as companion sort of domain, I think there are a lot of these subtle issues like, is this character personable? Does he, does this character scratch my itch for some definition of itch? And, for that sort of thing, maybe it turns out you need a human in the loop sort of evaluating fine-tuned Holmes in this case versus vanilla Holmes.
Got it. So are you telling me that fine-tuning is a little bit like method acting for LLMs?
I think so. But and the funny thing, by the way, it turns out that you can fine-tune a model with like 400 to 500 examples. And in this Holmes case, I think we took about 10,000 examples, and it could have been that some of those examples were actually lower quality. And so, just to give you an example, I just said, "Hey, Holmes, can you tell me a little bit about rugby?" And he said, I can't tell you. I've never played rugby. Basically, he said, no, I can't tell you. And I was just thinking, if we had trained this Holmes on fewer high-quality examples, we might have got a better result. And so there's this funny thing where more data is not necessarily better, right?
Right. I think that's a really great point. And before we move on from customizability as a topic, because there's so much more to cover, I do want to step outside this bubble of fine-tuning an LLM for a single task and maybe talk about how LLMs are being extended for more complex workflows where they're operating asynchronously, even autonomously. Peter G., I know you have a lot of experience with this. If you could share your insights on it.
GOD.
Yep.
So yeah, we did this interesting experiment a few weeks ago where we trained an LLM to be an asynchronous day trading bot. And just to show that I had some skin in the game, I threw $1,000 at it. And the funny thing is, I made about $3. And so I don't know if I can retire yet, but I have a 0.3% return, which is nice. But the funny thing is that even out of the box, using this thing called function calling, the LLM will actually learn how to act as an autonomous agent. And in order to pull that off, we had to do some classification tasks like, given these tweets, given these news headlines, are these bullish, are these bearish? And the funny thing was, every single tweet was bearish. I'm not sure why, and it always wanted to spend at least half of my money. But you know, and one of the things I was thinking is if you did something like a backtesting algorithm and maybe train the model in the last year of market data, you'd get an even better result. But I was kind of amazed what you could do out of the box.
Awesome. Well, I'm going to responsibly pivot this conversation to factuality because I think it's very relevant. Factuality is very important to enterprises. Recently, an airline's chatbot famously hallucinated a false refund policy. They're now being sued as a result of that. Peter G., perhaps describe to us what's happening under the hood when a chatbot hallucinates, and then we can discuss some approaches to dealing with that.
Yeah. That's a great question. So I think what's going on is exactly what we were talking about at the start of this talk was the model is just trying to do next word prediction. In some cases, the model is very certain about the next word. If you imagine a probability distribution over all the possible tokens, you get a really spiky distribution. In other cases, it might be much less certain. So I think that's one dynamic at play. The second dynamic that I think is really interesting is in a lot of cases, these models are trained to be helpful. And so after the pre-training stage, there's often a phase known as instruction tuning, where that's exactly what you're doing. You're coaching the model, you're instructing the model, you're teaching the model how to be helpful, how to follow results, or how to give results, how to follow direction. And so in a case where the model is unsure, especially if you've instruction tuned, instead of just simply saying, I don't know, or I'm not sure, the model might try to hallucinate something or make something up to try to be helpful and answer your question.
And what are some more advanced approaches that people can deal with hallucination?
Yeah. There's a couple things that we recommend. And so one is using a technique that you all might be familiar with known as retrieval augmented generation. And the idea there is that you want to use language models and a database together to solve the problem. And so you let language models do what language models are good at, which is generate natural language. And you let databases do what databases are good at, which is store, update, delete, ACL, facts. Then you train the language model to be able to retrieve the relevant information from the database and give an answer based on that context. And so in the airline example, hopefully in that case, it would have retrieved the actual refund policy and then maybe massaged it or summarized it or used that to answer the question.
Another hot topic is guardrails for LLMs. If you could just briefly touch on that as well.
Yeah, 100%. And so this is a topic that's super important. It's not important just for generative applications. It's important anytime you're building a machine learning system. But the idea is that frequently you take a stochastic machine learning model that's always going to have a little bit of randomness in it, and then apply a policy layer or a set of guardrails on top. And so in the Gemini, in the large language model day trading case, you might do something like, no matter how good the market looks, don't spend more than 10% of my money. Or no matter how good the market looks, don't put all of my money on GameStop. And hopefully that might limit the output space that you're thinking about and control the behavior a little bit. There's a really interesting case where you can also use LLMs to help evaluate that policy. And so you might have a layer on top that says, is this in the voice of the company? And give some examples of the voice of the company. Or is this a helpful statement? Is this a short and accurate response? And that could be another way to use LLMs as a policy layer as well.
It's worth noting that factuality, though, and these approaches, especially guardrails, can sometimes come at the cost of the user experience. Peter G., given your experience working with startups, especially these highly creative AI personas, perhaps you can share some insight on how this balance between factuality and creativity is met.
Yeah, there's this really interesting phenomenon. So, I noticed when startups come in now, one of the first things they do with the LLM is they turn off all of the safety features, right? And that's because there's this bizarre sort of optimization problem between safety and utility. And there are these cases where, just to give you an example, somebody wanted to do some multimodal analysis on, monuments, and they couldn't about 75% of the time because there was like a human face in the picture. And so that's one of these really sort of subtle dances, because I know, it's possible, for instance, that you could inadvertently maybe, let's say, fine-tune a toxic model. You turn off the safety filters, and all of a sudden, maybe there's sort of an embarrassing moment with your customers. And so anyway, there's this really subtle dance between safety and utility. And I think as a startup, maybe that's just some of the things that you have to be aware of when you go to market, right?
Awesome. For the purposes of time, I do want to shift to data privacy, because this is absolutely key for enterprises. I mentioned those two top selection criteria for model providers. Data privacy is actually number one. Peter G., businesses are very concerned about training models on sensitive customer data, about proprietary data being divulged through LLM prompting. Perhaps touch on what's the basis for this concern and what are some of the approaches that enterprises can take.
Absolutely. So there's a long history of data privacy and machine learning going hand in hand. For as long as there have been machine learning models, people have concerns about data privacy. And these can be well-founded. Many of you might be familiar with the Netflix challenge from about 10 or 15 years or so ago at this point. And even with a relatively constrained output space, either a ranking problem or a classification problem, should people watch this, they were able to reveal a whole bunch of sensitive information about the people in the data set. And so the first piece of advice I would give is don't ever train your model on sensitive data, whether it is a very simple classification model or whether it's a much more complicated generative model. Now, I think the reason that people are thinking about it so much in the generative case is the output space that you can produce in is much, much larger. Instead of true or false, yes or no, excuse me, the model can generate free text. And so to motivate this concern a little bit, if I prompted a model, Peter Grabowski's social security number is, hopefully it wouldn't be able to produce a valid response.
Now let's say a company here has a product workflow that is really centered on the exchange of sensitive data. What are some approaches to enable that exchange of sensitive data without having to actually train on it?
Good question. So one thing I would recommend is that retrieval augmented generation framework that we were talking about a moment ago. And that lets you store the sensitive data in a database where it can be appropriately ACLed. And then at inference time, at prompt time, you can inject that into the model and allow it to use it in its response.
Awesome. Now, just a tidbit I would add here is, for folks that are concerned about data privacy regulations like GDPR and HIPAA, RAG is very complementary in the sense that with a database, you can easily permanently delete data, of course. It's just a question of deleting tables and rows and tables. Additionally, you can localize that database, so you can ensure that data is not transferred outside of a specified geographic region. Both of those are very important to things like GDPR. There's another lens to this, though, Peter G., that I want to get your insight into, which is mistrust of businesses, I think especially startups, of closed source model providers, and using their model because they're concerned that the logs from that model, sensitive data, will be used to actually train the closed source provider's model.
No, you're absolutely right. And I think to that extent, startups tend to go with something like a Llama 2 stack, maybe a Gemma stack, a Mistral stack, because they can run a couple of GPUs and they control the entire thing from beginning to end. But what I've noticed, though, is that some startups tend to be using something like something called the long context window as an ad hoc form of RAG. And what that means is there's this promiscuous intermingling of kind of inference and possibly training data. And that gets dangerous when you're talking about things like law and insurance type of matters. So I think just having RAG is a form of data discipline, right? And so even if you're running your own open source models, you can still run into privacy issues if you're not careful. But I think also that's something that we're trying to do. I know Vertex AI is trying to basically be the, one of the pitches that they're making is that your data is safe with Google, right? And I think that's at least how we're trying to differentiate ourselves, right?
Awesome. Well, look, both of you, my brilliant colleagues, there is absolutely no way that we can cover all the information needed to know about how to productionize an LLM in 25 minutes. But you've done a really good job. And I just want to thank everyone for listening. I want to thank Peter and Peter. And if you do have any follow-up questions, if you didn't understand something, we're going to be in the Media Lab. So please feel free to come up to us and ask questions. And I hope you enjoy the rest of the program.
Thanks, folks.